Hello class, in this video we are going to talk about section 11.4, operations with rational expressions. So, we have two learning targets today. We want to perform operations with rational expressions in a real world example. And those operations we want to be able to do are add, subtract, multiply, and divide. Now, if you remember, when we defined a rational expression, it was a polynomial over a polynomial. So really what we're dealing with here are fractions. So let's back way up. Let's talk again about how to do these operations with fractions. If we are going to perform addition or subtraction, you need to make sure you have the same denominator. Alright? So you get a common denominator. Then you add or subtract the numerators, the denominators stay the same, and then you simplify from there. For multiplication, you multiply the numerators together, you multiply the denominators together, and then reduce the fraction. Division, this is that keep, flip, change thing we talk about, where we multiply by the reciprocal, all right? So we take that second fraction, we flip it, and then we multiply using the method we learned there. Now, of course, this is going to look a little bit different with what we're dealing with here, so let's get started. Example 1, we are going to multiply. We are going to multiply. The two rational expressions we have are x minus 2 over x plus 3. And we're going to multiply that by x plus 3 over x minus 5. Okay? So we're going to multiply those, and we also need to state the restrictions on the variable. Let's start with that. The restrictions on the variable. To figure out what the variable can't be for this denominator, we take the denominator, set it equal to 0, and solve. X is equal to negative 3. So what that tells me is x cannot be negative 3, because if it is, it gives us a fraction over 0, which again, we cannot have 0 in the denominator. What would kill this fraction? Well, take the denominator, x minus 5, set it equal to 0, and solve. X equals 5, which tells me x cannot equal 5, because if x was 5, we would end up with a 0 in this denominator, which again, would kill, or which is impossible. So our two restrictions will be x cannot be equal to negative 3, and x cannot be equal to 5, which we will add to our answer at the end. Now, let's go back to the operation we're performing here. So we're going to multiply this fraction by this fraction. When we multiply fractions, we know we multiply the numerators together, and we multiply the denominators together. So we're going to do x minus 2 times x plus 3, and in the denominator we're going to do x plus 3 times x minus 5. Now, before we multiply anything out, why don't we check to see if we can't cancel anything out? Simplify first. Because if you notice, I have an x plus 3 on the top and on the bottom, in the numerator and the denominator. So I can just cancel those out. So here's what that leaves me with. It tells me we end up with x minus 2 over x minus 5, with my restrictions being x cannot equal negative 3, and x cannot equal 5 from what we found before. So that is my final answer. So just to quickly recap, we first found our restrictions. Negative 3 would break this fraction, 5 would break that fraction. So that's where we came up with these restrictions. Then we went and actually multiplied these together, and instead of actually foiling them out, we looked for things we could simplify first, things we could cancel out. X plus 3 in the numerator, x plus 3 in the denominator, cancel out, leaving me with x minus 2 over x minus 5. Let's look at another multiplication problem. So this one, we actually have three rational expressions being multiplied by each other. We have, I'm going to write it a little further over this time, x plus 2 over 6x squared times x minus 3 over x plus 2 times 3x over 5. So we are going to multiply these, And then we're going to find any restrictions. Let's start by finding the restrictions. Start with my first denominator over here, 6x squared. Set that equal to 0 and solve. Divide both sides by 6. That gives me x squared is equal to 0. Take the square root of both sides. X is equal to 0. So what that tells me is x cannot be equal to 0, because if we plugged in 0 for x, it would break that fraction. Let's go on to the next one, x plus 2. To solve for x here, we subtract 2 from both sides, leaving me with x is equal to negative 2. So that tells me x cannot be negative 2, because if we plug in negative 2, it would break this fraction. And then this last one, since there's no variable, there's no value of x that will break that fraction, so we don't even have to worry about that. Let's then move on to the multiplication part. When we multiply fractions, we multiply the numerators, and then we multiply the denominators. Let's go ahead and do that. So here we'll have, I'm going to write the 3x first, times x plus 2, times x minus 3. That's multiplying all my numerators together. Notice I'm not simplifying yet. I'm hoping we're going to have some things that cancel out, so I'm not going to simplify quite yet. Then for my denominator, we have 6x squared times x plus 2 times 5. Now let's go ahead and see if we can cancel anything out. First thing I see is the x plus 2. I have an x plus 2 over an x plus 2. Cancel, cancel. Next thing I see, as I have a 3 over a 6, so this is going to turn into 1, this is going to turn into a 2. I have an x over an x squared, so I can get rid of the x on the numerator and one of the x's in the denominator. So let's go ahead and see what we have left over after all that canceling. The 3 is gone, the x is gone, the x plus 2 is gone, leaving me with just x minus 3 in the numerator. Then in the denominator, I have 2 times x times 5, or 10x. Looking at this, I see that there's nothing else that I can simplify. So that's going to be my final answer. And don't forget the restrictions we found. That x cannot be equal to 0, and x cannot be equal to negative 2. So my final answer is x minus 3 over 10x, with the restrictions of x not being able to equal 0, and x not being able to equal negative 2. So that's multiplication. Let's move on to division next. So we're going to go ahead and divide. So in this case we have x minus 2 over x divided by x minus 2 over x minus 3. And let's go ahead and find the restrictions. So first, let's look to see what breaks this fraction. So we set our denominator equal to 0, and hey, it's already solved for us. So we know x can't be equal to 0. If x was equal to 0, it would break that fraction. How about the next one, x minus 3? Set that equal to 0 and solve. That tells me x can't equal 3, because if I put in 3 here, it would break that fraction. But here's the thing, and this is special with the division problems. We have x minus 2 divided by x divided by this. This entire fraction cannot equal 0, which means we can't have 0 in the denominator or in the numerator, because if we had 0 in the numerator, we'd be dividing by 0, which again, we can't do. So we need to figure out what makes this numerator equal to 0. And again, this is special for division problems. So in this case, we're going to have an extra restriction, which is going to be 2. So x can't equal 0, x can't equal 3, because if x is equal to 0, it would break this fraction. If x is equal to 3, it would break this fraction. And x can't equal 2, because we can't have this whole fraction equal to 0. Because then we'd be dividing by 0, which is not allowed. All right, so an extra step to find a restriction there. Let's go ahead and actually perform the operation now. Now, if you remember, when we divide a fraction, we do that keep, flip, change thing, all right? Keep. The first fraction, we keep just how it is. Flip. We flip the second fraction. So this will now be x minus 3 over x minus 2. And then change, we change this from division to multiplication. Keep, flip, change. Another way to think about it is instead of dividing, we multiply by the reciprocal. So we change this to multiplication, and then we make this the reciprocal. And now we just follow the rules for multiplication. When we multiply straight across. So this leaves me with x minus 2 times x minus 3 in the numerator, and in the denominator, x times x minus 2. I see something that can cancel. The x minus 2's can cancel, leaving me with x minus 3 over x. And don't forget to list out those restrictions. X can't equal 0. X can't equal 3. And x cannot equal 2. So this would all be our final answer. So that is multiplication and division. Keep in mind when you do division, sometimes you gotta find that extra restriction. Keep a lookout for that. Keep a lookout for that. Now, let's move on to addition. If you remember adding fractions in the past, adding tends to be a little bit more difficult than multiplication and division. We need to be very careful when doing this. So here's what we're going to do. We are going to add x over x plus 2 plus x over x minus 1. Now, hopefully you remember. Well, actually, let's start just like we started the other problems. Okay, they're asking us to state restrictions. Let's go ahead and state our restrictions. So I know I can't have 0 in this denominator. So we take our denominator, set it equal to 0. So x cannot equal negative 2, because that would break this fraction. To figure out what breaks this fraction, set that denominator equal to 0 and solve. So x cannot equal 1, because that would break this fraction. Now let's actually perform the operation. When we add fractions, we need to make sure that we have a common denominator. So here's what we're going to do. In order to get common denominators, we are going to multiply both of these fractions by a really fancy form of 1. Because when you multiply something by 1, you don't change the value of whatever you're multiplying by 1. My favorite number is 11. 11 times 1 would still be 11. And even if I multiplied 11 by a really fancy form of 1, let's say 2 over 2, because 2 divided by 2 is 1, that would still give me 22 over 2, which equals 11. So even if my 1 isn't, doesn't exactly look like 1, if it's a fancy form of 1, it still will give me the same answer. So we're going to do that same thing here. We are going to multiply x over x plus 2 by a really fancy form of 1, which is x minus 1 over x minus 1. I got the x minus 1 from this denominator. And then we're going to multiply that second fraction, x over x minus 1, by a really fancy form of 1. This time, x plus 2 over x plus 2. And again, I got the x plus 2 from this denominator. So, we multiply our first fraction by the denominator over the denominator of the second fraction. We multiply our second fraction by the denominator over denominator of the first fraction. And here's what that's going to do for us. So we're left with x times x minus 1 over x plus 2 times x minus 1 plus x times x plus 2 over x, we'll write it in the same order, plus 2 times x minus 1. So now what we have is we have two fractions with the same denominator, therefore we can add them together. Let's do that. I'm going to leave the denominator as is. You can FOIL that out and write your answer as a quadratic trinomial. I'm just going to leave it factored though. But in the numerator, I'm going to go ahead and distribute. That x. So that's going to turn into x squared minus x over x plus 2 over x minus 1. So I just distributed the x to both terms. Same thing here, distribute the x to both terms. X squared plus 2x over x plus 2 times x minus 1. And we know when we add fractions, we add the numerators and keep the denominators the same. So my denominator will remain x plus 2 over x minus 1. In my numerator, we just need to add. X squared plus x squared is 2x squared. Negative x plus 2x equals x. What I like to do from there is I like to factor the numerator if I can. So in this case, I can factor out an x, leaving me with 2x plus 1. Then the denominator again just stays x plus 2 over x minus 1. And that there is as much as I can simplify. Sometimes you'll be able to cancel out one more thing. In this case, we cannot. So that's my final answer. Don't forget to add those restrictions. X cannot equal, what did I say, negative 2. And x cannot equal 1. Circle that whole thing. Oh no, I just lost it all. Oh. So that's addition. There we go. I fixed it. Magic, right? Not actually. I just rewrote the whole thing. But anyway, so we get our final answer of x times 2x plus 1 over x plus 2 times x minus 1 with these restrictions. A couple things I want to point out. First, as you can see, this is a ton of work, okay? Just like we did with the substitution and elimination problems, it is extremely important you show all your work, you keep it neat, you keep it organized, so I can give partial credit for things like this, all right? It's very important to keep your work nice and neat, okay? We don't want to be making little mistakes. We want to keep it as neat as possible to try to avoid those little mistakes. And again, so I can give you partial credit for things I like to see, all right? It is very important. Second, you can write your answer like this. This is an acceptable answer right here. The only thing you need to be careful about is sometimes when you factor the numerator, you can then simplify more with the denominator. In this case, you couldn't, so this answer would be fine. But to be safe, I recommend at the end, you factor your numerator as much as possible and look for things to cancel out. And that's how we add. One more example. Let's look at a subtraction problem. Very similar process. All right. And here's our last one. 3a over a squared minus 4 minus 2 over a plus 2. Let's start by finding those restrictions again. We like to do that at the beginning. So let's start with that first one. A squared minus 4 is equal to 0. Let's see what makes that equal to 0. Whoops, I want to be doing that in orange. So this one, I'm actually going to solve using square roots. I'm going to add 4 to both sides. I get a squared is equal to 4. Take the square root of both sides. A is equal to positive or negative 2. So what that tells me is a cannot be positive or negative 2. because it would break this fraction. Looking at this fraction, we take that a plus 2, we set that equal to 0 and solve. So what that means is a can't be negative 2 because it would break this fraction. Hey, it was already included in our first set of restrictions. Never hurts to be sure, though, that we don't have different ones. Let's go ahead and start our subtraction. Now, you may be wondering to yourself, what the heck do I multiply a plus 2 by to get to a squared minus 4? Very often, okay, you might see the correct answer already. Very often, though, it is beneficial to factor our denominator. So hopefully you see this as a perfect square minus a perfect square, meaning we use the difference of two squares pattern. So a squared minus 4, we take the square root of the first term, square root of a squared is a, we put that here and here. Take the square root of 4, put that here and here. Make one plus, make one minus. A squared minus 4 is the exact same thing as a plus 2 times a minus 2. Which makes this side easier because now you're looking at this, you're like, oh, well I already have an a plus 2 in the denominator, so I'm just going to need to multiply by a minus 2 on the top and bottom to make our denominators the same. So here's what this turns into. 3a over a plus 2 times a minus 2. And then I'm going to write this like this. Plus negative 2 times a minus 2 over a plus 2 times a minus 2. Be very careful when we change our subtraction into the addition of the opposite that we only make the numerator negative, okay? We only want a negative on the top or a negative on the bottom, but you can't assign a negative to both because then they cancel out and become positive. So if you're going to rewrite a subtraction as an addition of the opposite, make it plus, and just make the numerator negative, like I did there. Now we just got to simplify. So 3a over a plus 2 times a minus 2 plus, I'm going to distribute this negative 2. Negative 2 times a is negative 2a. Negative 2 times negative 2 is a positive 4 over a plus 2 times a minus 2 equals 3a plus 2a, I'm sorry, 3a plus a negative 2a is just a. Nothing plus 4 is 4 over a plus 2 times a minus 2. And don't forget to list out your restrictions. Which were a cannot be equal to, let's just write positive or negative 2. If you wrote a cannot be equal to 2 and a cannot be equal to negative 2, that would be just fine as well. And being very careful not to erase my board this time, there is our final answer. So, you need to remember your rules for adding basic fractions. Because the rules for doing operations with basic fractions. Because the rules for doing these are the same. It's just a little more complicated when we start to throw variables in the mix. So that's operations with rational expressions. We learned how to add, subtract, multiply, and divide rational expressions. These are tough. They take practice. Do your homework.